Hybrid search is the ability to combine vector search with keyword-based search. Pretty cool, huh? It's optional, meaning Vearch can do just vector search, but also has the potential to blend the two for even better results. Vearch comprises several components working together. These include data nodes, index nodes, and other elements that enable it to perform its functions efficiently. Understanding these components helps grasp Vearch's architecture. High availability means that Vearch is designed to remain operational even if some components fail. Imagine it like a super reliable car that keeps running even with a flat tire. This is critical for applications that cannot afford downtime. Scalability refers to Vearch's ability to handle increasing amounts of data and user traffic. Think of it as a restaurant that can easily add more tables when it gets busy. This is achieved through its distributed architecture. Vearch stores vectors and creates indexes to enable fast similarity searches. Indexing is like creating a table of contents for a book. It allows Vearch to quickly find the most relevant vectors. The Vearch cluster is a group of interconnected Vearch servers that work together as a single system. This distributed setup enhances performance and reliability. These are the documents retrieved by Vearch that are most similar to the query vector, often refined by metadata filtering for greater accuracy. Metadata filtering allows you to narrow down search results based on specific attributes associated with the vectors. It's like adding filters on an e-commerce site to find exactly what you're looking for. For example, filtering by date, author, or category. Similarity search is the core function of a vector store. It involves finding vectors that are most similar to a given query vector, based on distance metrics like cosine similarity or Euclidean distance. A vector embedding is a numerical representation of a piece of data, like text or an image. These embeddings capture the semantic meaning of the data, allowing Vearch to compare them for similarity. This is the input from the user, which could be a question, a search term, or even another vector. This query is then converted into a vector embedding to find similar vectors in the vector store. This refers to the broader application built using Langchain, where Vearch serves as the vector store to manage and search embeddings. This describes how Vearch is set up and functions as a vector store specifically within the Langchain framework, highlighting its distributed nature and key capabilities. Now, let's examine how the provided text assesses option A, which pertains to Vearch's distributed architecture and scalability. This section validates that Vearch does leverage a distributed architecture. This architecture is essential for managing large datasets common in Langchain applications. It ensures both scalability and high availability, thereby making option A correct. Here, the evaluation addresses option B, which discusses metadata filtering support in Vearch. The provided content correctly identifies option B as incorrect. Vearch does indeed support metadata filtering. This capability allows users to refine search results based on specific criteria linked to documents or vectors, a crucial feature for targeted retrieval in Langchain. The assessment of option C focuses on the types of vectors and search functionalities supported by Vearch. This section acknowledges that Vearch effectively handles dense vectors, especially in high-dimensional spaces. The text clarifies that while Vearch supports dense vectors, its capabilities extend to offer hybrid search functionalities, thus making the claim that it only supports dense vectors incorrect. Now, the focus shifts to option D, which concerns the search algorithms employed by Vearch, specifically approximate nearest neighbor, or ANN. The evaluation confirms that Vearch utilizes ANN search algorithms, which are critical for achieving rapid retrieval, particularly with large datasets. ANN algorithms prioritize speed, allowing for efficient queries even with billions of vectors, at the cost of some accuracy. Therefore, option D is deemed correct. Based on the evaluations in the preceding sections, this segment explicitly states the correct answers. The provided text determines that options A and D are the accurate statements describing key characteristics and functionalities of Vearch as a vector store. Now, let's examine the core challenge. This outlines the quiz question, requiring evaluation of several statements related to Vearch's characteristics and functionalities within Langchain. The task involves determining which statements accurately reflect Vearch's capabilities as a vector store. Statement A posits that Vearch employs a distributed architecture. Distributed architectures are crucial for managing extensive datasets, especially for tasks like document indexing and retrieval. This distribution contributes to scalability and high availability, meaning it can handle increasing data volumes and remain operational even if parts of the system fail. Statement B suggests restricted metadata filtering capabilities in Vearch. Metadata filtering is the ability to refine search results based on attributes associated with data, such as date, author, or category. A vector store's utility significantly increases with robust metadata filtering, enabling precise information retrieval. Statement C focuses on Vearch's vector handling and search capabilities. Dense vectors are numerical representations of data points, optimized for similarity searches. High-dimensional spaces refer to datasets with numerous features or dimensions. Hybrid search combines vector-based semantic search with traditional keyword-based methods. Statement D highlights Vearch's search algorithm. Approximate nearest neighbor, or ANN, search is a technique used for efficiently finding the closest data points to a query in a large dataset. While not perfectly accurate, ANN provides a significant speed advantage, particularly when dealing with billions of data points. Let's discuss option C. Vearch indeed excels with dense vectors in high-dimensional spaces, optimized for similarity search. However, stating it offers no hybrid search capabilities is incorrect. Modern vector databases, including Vearch, increasingly support hybrid search, combining semantic and keyword-based methods. Now, let's consider option B. This statement suggests that Vearch has limited metadata filtering, confining it to semantic similarity searches. This is inaccurate. Vearch does support metadata filtering. This feature refines search results based on document or vector characteristics, enhancing targeted retrieval. Let's discuss option A. Vearch utilizes a distributed architecture, vital for handling extensive embedding datasets common in applications. This design ensures scalability and high availability, making it suitable for indexing and retrieving large volumes of documents. Let's examine option D. Vearch employs approximate nearest neighbor, or ANN, search algorithms. This enables fast retrieval, particularly with large datasets. ANN trades some accuracy for speed, enabling efficient queries on billions of vectors. Now, let's consider the question: which statements describe Vearch's key traits or functions as a vector store within Langchain? Keep in mind that multiple answers might be right. Let's start with a multiple-choice question focusing on Vearch as a vector store within Langchain.